Today's notes are section 5.5 from the book, and they are on solving equations by factoring or taking square roots. So up to this point, you've done a lot of factoring. You're trying to figure out what are you going to do with factoring. Well, in order to solve equations, a lot of times the best method to solve an equation is to factor it. We can also take square roots. So I'm going to show you both methods. Some problems you can do both methods. Some problems you can only do one method. But realizing what method to use when is important and which method you're quicker at as well. So we're going to solve and check the following equations. What I mean by check is, you can check any of these equations for your solutions. You don't have to spend that much time making a formal check, but recognize that you can, just like factoring, you could FOIL out to get your answers. When you solve and check these, you can check your solutions to see if you actually solved correctly. So take a look at number 1. When we solve, the difference between number 1 and what you've seen so far, or in previous homeworks, is x squared plus 7x plus 10 is what you saw before, just kind of like that, right? But hold on, let me get my pen. We stopped like right here. We didn't have this equal to 0. And now we have an equal to 0. So what we're trying to do is we're trying to use factoring, but we're trying to solve the equation. So what we're going to do is kind of pretend like that 0 is not there. If I just asked you what multiplies to give you 10 and adds to give you 7, what two numbers would do both of those simultaneously? So 5 times 2 would multiply to give me 10. It would add to give me 7. So I'd say, okay, x plus 5, x plus 2. Just like you've typically done in factoring. However, now you have your left side is equal to 0. So I need to find out answers. I'm actually finding numbers that will solve the problem. And there's something called the zero product principle. Zero product principle. And all that means is to get 0, when you multiply the product, if I have two things multiplied to give me 0, one of them has to be 0. So like if I have x plus 5 times x plus 2, one of those numbers has to be 0, because if they're multiplied and equals 0, that's the only way that's possible. So what you do after you factor is I'm going to say either x plus 5 is equal to 0 or x plus 2 is equal to 0. And then solve for your x. So just subtract 5 over, so that'd be x is negative 5. Subtract 2 over, that'd be x is negative 2. And those are the two solutions you get for number 1. Now again, you want to kind of do a quick check and see if those work, meaning if I plug in negative 5 back into my original equation, the left side should equal the right side. You don't ever cross the equal sign. I would plug in negative 5, so that'd be 25. Negative 5 times 7 would be negative 35. Plus 10, I'm asking, does that equal 0? And if you put these all together, negative 35 plus 35 would be 0, so 0 does equal 0. And you do the same with negative 2. Every solution you have, you can go back in and check it. That'd be 4 minus 14 plus 10. Does that equal 0? And it does, so this answer does check as well. All right, number 2. The biggest issue we need to have, or make sure we take care of when we solve, is you've got to start by setting the equation equal to 0. All right, so make sure on your notes that you talk about setting equal to 0. Number 1 was already done for me, but if you look at number 2, I can't like pull out an x, so don't do this, but I can't pull out an x and do this and be like, oh, either x is 18 or that you have no idea. Unless it's equal to 0, and we can use the zero product principle, you cannot factor and set it equal to a number. So make sure that you always set your original equation equal to 0 before you start factoring. So I'm going to say x squared minus 3x, I'm going to subtract over the 18 and say that equals 0. Don't forget that it's an equation, so you have to bring down the equal 0 for every step. If I factor this, what multiplies to give me negative 18 adds to give me negative 3, it would be minus 6 and positive 3. Those two binomials multiplied together equal 0. Because it's two things multiplied to give me 0, either x minus 6 equals 0 or x plus 3 equals 0. So when I solve, I'm going to get 6 and I'm going to get negative 3. So here are my two solutions to this equation. You can go back in and plug back in. So it's like 36 minus 18. Yes, 18 equals 18. Plug back in negative 3. 9 plus 9 is that 18, and it is. Okay, so you can do an informal check, but just know that you can always check your solutions in your original problem. Okay, number 3, we have the coefficient of 6, and we have x squared on one side and the 7x plus 5. I know I want to get everything on one side, but one hint I want to tell you is you want to keep the highest degree So like if it's an x squared in this problem, you want to keep that positive. It makes it easier to solve whether you're factoring or taking square roots. So what I mean by that is I'm going to keep the 6x squared on the left side, and I'm going to move over the 7x and the 5 to the left side. So those would become negative 7x minus 5, and now it equals 0. Because it's easier for me to factor, we typically factor with this coefficient being positive out here. It's possible to do it with a negative, but typically it's easier for most of you guys to factor with a positive coefficient. This would be a problem where you have to guess and check, meaning what two numbers multiply to give me 6x squared? Let's try 3x and 2x. And then multiplying to give me 5, it's got to be 5 and 1. So let me try 5 here and 1 here. I would get 3 and 10. Would that give me negative 7? And that would if the 3 was positive and the 10 was negative. So I have 3x minus 5 times parentheses 2x plus 1 equals 0. Now I'm going to solve just like the other ones. It's a little easier on 1 and 2 because if you look back, like x minus 6 turns to positive 6, like plus 3 turns to negative 3. But now I have a coefficient out front. So some of you will be able to do that mentally, but if not, you still make two equations. Just set that equal to 0 and solve for x. So I would add 5 and divide by 3. So my first solution is 5/3. The second one, I would say 2x equals negative 1, so x equals negative 1/2. So my two solutions are fractional, which obviously is going to be less fun to check, but you can still check those to make sure that your answers are correct when you're doing a problem, especially when you're doing it on a quiz or an assessment. All right, let's look at number 4. Now I'm going to solve this by factoring, and then I'm going to show you another way of solving by taking square roots. So I'm going to kind of put an F here for factoring, and then I'm going to show you square roots. I'm going to show you how to solve by that method. So kind of make two little columns here. Okay, if I solve this by factoring, my first factoring technique is always to do a GCF. So if you look, these two terms both share a 2. So if I pull out a 2, I'm going to x squared minus 6 equals 0. Now I cannot factor x squared minus 6 anymore, okay, because 6 is not a perfect square. However, I can actually, since I'm fully factored, 2 times this is equal to 0, I'm going to set them both equal to 0. Now you'll recognize that when I set a coefficient equal 0, that's just going to get rejected because 2 can't equal 0. So that's kind of inconsequential in my answer. If I say x squared minus 6 equals 0, let's go ahead and solve. So if I add 6, and then take the square root. Just be careful when you take square roots. You always have two solutions. You have a positive and a negative. I don't know the square root of 6, and I can't simplify it, so I'm just going to leave my answer as x equals plus or minus root 6. So that's how to solve that problem by factoring. If I want to solve that problem by taking square roots, the difference in setting up to taking square roots is I want to isolate my x squared term. So when I'm solving for square roots, what I mean is if this is my original problem, the first step I want to do, I don't want to leave it equal to 0. I actually want to isolate my x squared term, meaning I want to get that by itself. So in order to get 2x squared by itself, I'm just going to add the 12 on the other side. To isolate the x squared further, I've got to divide by 2. So I have x squared equals 6. And if you see, I'm now exactly at the point I was with factoring where when I take the answer, or to get the answer, I have to take the square root of 6, so it's plus or minus root 6. So it doesn't matter which way you solve, you're going to get the same answer, no matter if you do it by factoring or square roots. Sometimes I think the square roots is a quicker method, but a lot of you get so good at factoring that that's your preference. All right, number 5, I can't solve this one by square roots, because when I have a problem that I can solve by square roots, it has to be a square term and a number. If you look at number 5, I have a square term, but I have an x term. So I'm not going to be able to solve this problem by square roots. What I can do, though, is factor out an x, so I'm left with 4x minus 3 equals 0. This is as fully factored as I can get it. I have two things that multiply to give me 0. So either x is equal to 0 or 4x minus 3 equals 0. Now, x equals 0, I don't reject that. That's a solution. I'm saying my x can be 0. It is different from when I pulled out just a plain old coefficient. Like over here, I had a 2. 2 does not equal 0. That gets rejected. But x equals 0, that's truly a solution. Then 4x minus 3, let's solve for x. So 4x equals 3, and I would get 3/4. So the two solutions to this problem would be x equals 0 and x equals 3/4. All right, let's look at number 6. Now, number 6, I have stuff all over the place. Let's try to isolate. Since I've got square terms, x terms, and numbers, I probably won't be able to do it by square roots. I can't totally tell, but let's start by getting everything on one side. So I'm going to move everything on this side of the equation over. So if I added x squared, I would get 2x squared. If I subtracted 3x, let me actually write these steps out for you all. 3x equals, let's say 3x plus 36. Let me do these at the same time. If I subtract 3x and then I subtract 36, because I'm moving everything over to the left side, this goes away to give you equal 0. This side, the 36 cancels, so that's nice. I'm left with 2x squared plus 9x. Now, right away, I want you guys to recognize I cannot solve this by square roots because I have an x term. Okay? If you have an x squared and an x term, I'm going to have to factor. So factoring, pull out a GCF of x. I have 2x plus 9 equals 0. X is equal to 0 is one solution. And if I were to set this equal to 0, I would get 2x equals negative 9. So my other answer would be negative 9 halves. And again, you can plug this back into my original equation to check to see if they'll work. All right, number 7, I'm going to show you both methods on 7, and I'm going to have you try number 8. So number 7, I'm going to start by factoring, all right? And then I'll do the square roots right over here. So if I look at this original problem, if I'm solving by factoring, you've got to remember when you solve by factoring that everything has to equal 0. So I'm going to subtract the 80 over to the left side. So when you factor, you've got to set it equal to 0. Then do your GCF of pulling out a 5. If I pull out a 5, you get x squared minus 16 equals 0. Now this isn't fully factored because x squared minus 16 is a difference of squares. So I'm going to leave the 5. I'm going to say, okay, a difference of squares would be x plus 4 and x minus 4, and this is still set equal to 0. Right, if I set these three things equal to 0, because they're multiplied to give me 0, 5 does not equal 0. That's just going to kind of go away. But my x is going to equal negative 4, and then the other one's going to be positive 4. So here would be the two solutions for number 7. If you wanted to do this by square roots, this would be a good example of where square roots might be a little simpler. Because square roots, if I just have an x squared term and a constant, if I want to isolate the x squared, it's kind of started for me. I just have to divide by 5 to finish it and get that x squared isolated. And I say, okay, when I take the square root of 16, just make sure you always remember to do plus or minus. X squareds, you have two answers, the plus and the minus. The square root of 16 is 4. So it's a little shorter sometimes to do it by square roots, but you can solve by either method. All right, so try number 8 on your own. Press pause, and then come back to it and just double check your work. So for number 8, if I start by factoring, this is a difference of perfect squares, and it's set equal to 0, so I can just jump in and say 5x minus 3, and then 5x plus 3 is equal to 0. So if I set each of these equal to 0 and solve for x, I would get add 3 divided by 5, so 3/5. I would subtract 3 divided by 5 and get negative 3/5. So these are the two solutions to number 8. If I wanted to solve this by square roots, again, the first step for square roots is to make sure that you isolate the x squared term. So in my first step, I'm going to say 25x squared. I'm going to move over the 9 and make equal positive 9. Since I'm isolating the x squared, I want to divide by 25. Now I don't know what 9 over 25 is, so just leave it for now. It will actually work out nicely when I go to simplify. If x squared is 9 over 25, if I take the square root of both sides, make sure you get a plus or a minus. The square root of 9 is just 3, the square root of 25 is just 5, so I get plus or minus 3/5, which is exactly what I got when I factored. So just make sure you recognize that you can solve equations by factoring or taking square roots. When you factor, you need to set equal 0. When you have a highest degree, you want to keep that positive. And when you're using square roots, you want to make sure that you isolate the x squared.